Right, lana ngiphethe question 6, which is a question on a wave phenomenon and wave properties. So longitudinal waves, transverse waves. In this video sizobe sikhuluma ngakho lokho. This is a question from this question paper ka November 2018. In the description below, you'll also find the links for other questions engiwaphendulile for this question paper. Now, question 6, but he studied the two transverse waves P and Q as shown below. So, wave P, the solid line, it represents two wave P, and then I have wave Q, which is the dotted line. So on the y-axis, I have the position measured in millimeters, and then on the x-axis, time in seconds, right? 6.1, write down one difference and one similarity between wave P and wave Q. So mawuthatha ukubheka ke la, wave P no wave Q, there are differences and similarities. So for the first one, 6.1, let's spot the difference between the two waves. Mawuthatha ukubheka the two waves, I can see that ngine different amplitude la. Ama-amplitudes wakhona akafani. Checka la. Alright, asibheke wave P. Wave P has wave Q. Wave Q has an amplitude of 10 millimeters, and then wave P has an amplitude of 15 millimeters. So there's a difference in amplitudes between wave P and Q. What are the similarities? Mina ngibona frequency, since they have lama waves way 2, they are in phase in similar points. So therefore it's frequency, and mawuthatha ukubheka from B to D, from B to D is actually the wavelength. So the wavelength is also the same between the two waves. So singathi frequency, the similarities frequency as well as the wavelength. But a one, you can choose the frequency or the wavelength. So I just wanted to point out both similarities. 6.2. With 6.2, but for wave P, the solid line wave, write down 2 points that are out of phase. Points are in phase. Points like crest, throw, or bottom. So points are out of phase. Ungakhetha i-crest or i-peak ne bottom. So lana 6.2.1, points that are out of phase, it's A and B. Since A peak and then B bottom. Points in phase, points like njengoba bengibekisa, crest points in phase, bottom points in phase. Out of phase, you just choose the opposites. And then 6.2.2, the amplitude of the wave P, I think on the 6.1 I did show that it's 15 millimeters. Sikhuluma wave P. Wave P is the solid line, so from lana, so from here, from this point to that point is 15 millimeters. 6.3. With 6.3, but it defined the term frequency of wave in words. So siyazi with the frequency is calculated by saying 1 divided by period. It's 1 divided by period, and the answer is nikeza ini frequency. So the frequency can be defined as the number of waves passing a point per second, right? Frequency is the number of waves pass a point per second, right? And then lana 6.4, 6.4.1 bathi for wave Q, siya ku wave Q. Wave Q is the dotted line. 6.4.1, calculate the frequency of the wave. Frequency is calculated as 1 over t, which is the period for that wave. Okay, bheka ke manje, it's 1 over period. The period is 1.5 for Q. Bheka ke wave, like it's the period taken. Period is the time taken to complete one wave. So from lana, from this point to lana ku 1.5, I have a complete wave. Why ngisho njalo? Nginani, ngine peak. A wave is formed by a peak and a bottom. So a combination of a peak and a bottom inginikeza one complete wave. And the time taken to complete that wave, a peak and a trough, it took about 1.5 seconds. So 1 divided by 1.5, and this is equal to, let us calculate. So it's 1 divided by 1.5, 1.5. 1.5 is 0. When we have a calculator, 0.67. 0.67 hertz. Frequency is calculated as hertz. So this is our final answer, 6.4.2, which is the last question. We need to calculate the speed of the wave. The speed of the wave is calculated as v equal to frequency times the wavelength, or my calculator as distance over time. But since in our wavelength, I just calculated the frequency. What's the point of using the other one? So I say this one, frequency is calculated as 0.67 times the wavelength is 100 millimeters, which is the same for both P and Q. So the wavelength is measured from bottom to bottom, or from crest to crest. So lana by measure from bottom to bottom, which is 0.1. Remember, kwamele ucalculate using ama-meter. So 100 divided by 1000 inginikeza ama-meters. We are converting from millimeters to meters. So it's 0.1. 0.67 times 0.1 is equal to 0.067. 0.067, right, meters per second. Wow, the wave is slow, yo. But anyway, this is our last question for this question 6. So thanks for tuning in. Now we enjoy this video. Ungakhohlwa ukushare nabangani bakho, ungakhohlwa ukulike, ungakhohlwa ukucomment, ungakhohlwa ukuchecka the videos engiwarecordile in the description below for this question paper. So yeah, asibonane on the next video. Thanks for tuning in. Bye bye guys.